Hi everyone and welcome back to the GCSE Maths series. Today we're going to be taking a look at exam style questions for our similar shapes topic. Before I get started, I just want to make sure that you guys check out Maths Junior because I am using their questions today. Also, if you have not watched my revision video on this topic, I strongly advise you to do so that you can use this video to consolidate your knowledge rather than learn from this video. Okay, let's get straight into it. BE is parallel to CD. ABC and AED are straight lines. AB is 4 centimeters, BC is 6 centimeters, BE is 5 centimeters, and AE is 4.8 centimeters. Calculate the length of CD. So we need to work out the length of this line here. Okay, first things I'm noticing, these two lines are parallel. Two parallel lines are going to create what we know as corresponding angles. And if I go back to my notes, it tells us for two shapes to be similar, all corresponding angles are going to be equal. Okay, now we know that corresponding angles have been formed and that corresponding angles are going to be equal. So they're going to be equal because angles on a straight line add to 180. So these angles are going to add to 180, making these angles, this angle and this angle, equal. Hence, we know that the two triangles ABE and ACD are similar. Hence, we can use our ratios. So, looking at this side for our big triangle is going to be 10 centimeters, whereas in the smaller triangle, it's going to be 4 centimeters. This side is going to be 4.8 centimeters from what we know here. And then we know that our 5 centimeters is going to be here. And we need to work out our CD. So, we can use our scaling formula by saying the scale factor, or the length scale factor to be more specific, is the length of larger shape over length of smaller shape. Hence, our length scale factor is going to be 10 over 4, which is equal to 5 over 2, or 2.5. That's our length scale factor. Now, looking at the question again, we need to calculate the length of CD, which is this one here. And if we're looking at the two shapes, which shape in ABE, the smaller triangle, corresponds to our CD? It's going to be our BE, right? This one here. It's going to follow the same ratio and the same scale factor to get from there to there. So hence we do 5 times by 2.5 to get equal to 12.5 centimeters. Hence the answer to this is 12.5 centimeters. Okay, calculating the length of E to D, we now need to realize, okay, so our bigger triangle is from A to D, right? So let's first obtain that. We have our smaller value, which is 4.8. So 4.8 times by our 2.5 is going to be equal to our 12 centimeters, which tells us that the whole length of AD is 12 centimeters. But we're not trying to work out AD in this situation. We're trying to work out ED. So ED is going to be 12 centimeters minus our 4.8. So 12 minus our 4.8. That's because ED is only this section of our larger line. So 12 minus 4.8 is going to be equal to 7.2 centimeters. Moving on to the next question. So we are told that AB is parallel to DE. ACE and BCD are straight lines. AB is equal to 6 centimeters, AC is equal to 8 centimeters, CD is equal to 13.5 centimeters, and DE is equal to 9 centimeters. And we need to calculate the length of CE, so this one right here. Okay, once again, because we know the lines are parallel, it's going to form our corresponding angles. So we now know that our triangles are going to be similar. So this is going to be 9 centimeters because this is DEC. Once again, C is at the top here, but this is going to be B and A, like such. Because we're cutting off our triangle here and placing them next to each other. So this line here is going to be 6 centimeters. our DC is going to be 13.5 and our AC is going to be 8 centimeters. To calculate the length of CE, we need to work out this one. And the one that corresponds to our CE in the smaller shape is our CA. So our CA is 8 centimeters, as we know. First of all, we need to now work out our scale factor, our length scale factor. And remember, we do this by doing the length of the larger one divided by the length of the smaller one. So we look at what's in common for the ratios. These two are the base of the triangle, so we can use them. So 9 centimeters over 6 centimeters is going to be equal to 9 divided by 6 is equal to 3 over 2. That's our length scale factor. I remember when we're doing scale factor, they have to be the same corresponding. And when I mean corresponding, the one that the side that represents the side in the larger shape. So as you can see in these two triangles, the bases are what we can use to work out the scale factor. So now working out CD, we know that 8 centimeters, our C to A, corresponds to our C to E. So 8 times by 3 over 2 gives us 12 centimeters, and that is our answer. Okay, calculating the length of B to C, this one here, we know that 13.5 corresponds to our BC, and because we're starting off in the larger shape, we need to do 13.5 divided by 3 over 2. Put this into our calculator and we get this to be 9 centimeters. Remember, if we're going back from the larger shape, we divide by the scale factor. And if we're going from the smaller shape to the larger shape, we times by the scale factor. Okay, looking at the larger question today, it says that a 20 euro note is a rectangle 133 millimeters long and 72 millimeters wide. A 500 euro note is a rectangle 160 millimeters long and 82 millimeters wide. Show that the two rectangles are not mathematically similar. So it tells us that the 20 euro note is as such 133 millimeters and 72 millimeters wide. A 500 euro note is 160 millimeters long and 82 this way. So the scale factor for our length is going to be 160, the length of the larger one, divided by the length of the smaller one, which is equal to 160 over 133. Now, for the two shapes to be mathematically similar, the ratios must be equal for all of them. So for all sides, the ratio should be equal. As we saw here in previous questions, the 9 and the 6 had the same ratio as 8 and our 12, and our 9 and our 13.5. That's how we know our shapes are mathematically similar. So our width scale factor is now going to be, our long one is 82 and our short one is 72, which simplifies to 41 over 36. As you can see, 160 over 133 is not equal to 41 over 36. Therefore, we can conclude that the shapes are not mathematically similar because the ratios are not equal for length and width. Okay, that's going to conclude today's video on exam style questions of our similar shapes topic. As always, please make sure to like, comment, and subscribe, and I'll catch you guys in the next video. Peace.